This video is on section 4.1 notes, reading and constructing graphs. So throughout these notes, we're going to go over a couple different types of graphs that you'll be reading and constructing. And the first one is bar graphs. A bar graph is used to display and compare the sizes of different but related quantities. So here's an example of a vertical bar graph that shows the average annual health care cost per person in 6 different countries in 2015. So you can see that you have a vertical axis that has the cost per person in dollars. You have a horizontal axis that has all the different countries, and you'll notice that between those countries there are equal spaces. So for each of these, we're just going to answer a couple questions and then move on to another representation of a graph. So this question says the population of the United States in 2015 was about 321 million. So hundreds, thousands, millions. What was the total cost of healthcare in the United States in 2015? So this graph is the annual healthcare cost per person in various countries. So this is for an individual person, just one. The average healthcare cost, this looks to me to be about in the middle, I would say. So 9,000, 10,000, so 9,500 for one person. So I would say 9,500 for one person multiplied by 321 million people. And if you multiply this in your calculator as it is, you're going to get an answer in scientific notation. And I'll show you. Which is just a confusing answer to get. So an alternate way to multiply these numbers is to just multiply the numbers themselves and not do the zeros. 95 times 321, like this. And this is a trick that only works when you have extra zeros in a problem. It doesn't work if it's another number. So I'm just going to write this down, 30495, and you can see that. You can see those digits there. 30495, and then I'm going to count the number of zeros and just stick them on the end. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's how much money it would cost for healthcare in the United States for all of the people. So this is hundreds, thousands, millions, billions, trillions. So a little over 3 trillion. By what percent did the cost per person in the United Kingdom exceed that of Italy in 2015? So the United Kingdom was $4,000. And Italy was a little above 3,000. Let me see if I can. Maybe about halfway between there. So if this is 3,500 right here, then halfway would be about 3,250. So I'm going to say 4,000 divided by 3,250. So if you're trying to find a percent, you can divide the percentages. And if you want to see how the United Kingdom exceeded Italy, then you can do the United Kingdom divided by Italy. So United Kingdom divided by Italy is this much. I'm going to write this down, 1.2308. Now this 1 is for 100%. So if I want to see how much more they had, 100% means they had the same amount. The rest of this is how much more, how much it cost that was more than that per person. So I'm going to minus 1. This is the amount extra we had for the percentage, and then I can multiply this by 100 or take the decimal and move it over twice. So 23%. So take away the 1, I get 0.2308, and then if I want this written as a percentage, I can just move the decimal place twice, and I get 23%. The cost per person in the United Kingdom exceeded Italy by 23%. All right, for the next one, it says the following bar graph compares the approximate costs of driving 7 different fuel-efficient cars over a distance of 25 miles. These are based on gas costing $2.25 per gallon and electricity costing 12 cents per kilowatt hour. So we have a few different types of cars here. On the side, you'll notice that there's spaces in between each one. And then across the horizontal axis, we have the cost to drive 25 miles. So it says, how much would it cost to drive a Hyundai Elantra 5,000 miles? So this is only 25 miles. We want 5,000. So a Hyundai Elantra, so it looks like this is going up by 10 cents, 160, 170, 180, 190. So I'd say this is about 170. You could say it's in between if my line was perfectly straight. So I'm going to say it's 170 for 25 miles. So 5,000 miles. And the cost is 150, but that's for 25 miles. So I'll do a little unit conversion here. It's not 150. Sorry, it was more than that. I'll say about 170. Or if you wanted to say maybe like 168, let's do that. 168. 168 for 25 miles. So the miles are going to cancel out and we're going to end up with just the cost. So I need to multiply by the number on top, 5,000 times 1.68, and I'm going to divide by the number on the bottom. So $336 is how much you would pay to go 5,000 miles. By what percent does the cost of driving a Kia Forte exceed that of a Tesla Model S? So the Kia right here, and the Tesla. Okay. So the Kia is about 180. The Tesla is about 105. And this is just like that last page, the problem that we did. So we're just going to divide these. So I've got 1.7143. I'm going to take away the 100%. The 100% is the part of the price that costs the same. That's the $1.05. And then I'm going to move my decimal over twice. 71%. So the cost of the Kia is 71% higher than that of the Tesla to drive. And whenever you are doing problems like this and you're reading a graph like this, you're always estimating. So I'm going to show you when I was doing this problem ahead of time on my own paper, I ended up using $1.75 for the Kia, and I ended up with 67% exceeding. And so it's going to depend on how you see the graph. And usually when we answer questions like this, there's a range of answers that would be acceptable. So you don't have to worry like, oh, did I get the perfect answer? You're just trying to get a reasonable answer based on seeing the graph. So if somebody said 20% here, they're definitely wrong. But answers that would be correct would be answers that are around this. All right, here's another problem. It says the following stacked bar graph compares the average cost per gallon of gas in 9 different countries during the spring of 2016. The lighter lower section of each bar shows the portion of each price that is represented by taxes. The scale of the graph allows us to estimate the cost to the nearest 25 cents. So here we have our countries, here we have our cost in dollars. The bottom portion is what they were talking about. This is the portion of your gas price that is contributed to taxes. And then the top price is just the price of the gas overall. All right, so it says, what was the average price of a gallon of gas in New Zealand and how much was represented by taxes? So in New Zealand, the gas, it looks like, if I had a straight edge, this would be a lot easier. So it looks like in New Zealand, the gas prices are about $5.25. And the portion that is represented by taxes would be up to here, the second line, which is $2. So a gallon of gas is $5.25, and $2 of that contribute to taxes. In Germany, what percent of the total cost per gallon was represented by taxes? So in Germany, the entire cost of a gallon of gas is probably about $6.25. So $6.25 is the entire cost. And then the cost for taxes looks like it's about $3.25, maybe a little bit more than $3.25, maybe like $3.30. So if we wanted to know what percent of the total cost was represented by taxes, then we would do $3.30 is the portion divided by the whole, which is $6.25. So this is our percentage. It's written as a decimal. So I'm going to move my decimal place over twice. So 52.8% or 53% of the price of a gallon of gas is represented by taxes. All right, here it says, suppose you want to display the following data in a bar graph showing sales of DVD players and televisions in 5 stores. So what we're going to do is we're going to do a horizontal bar graph, and we're going to go ahead. We can see that the data goes from 65 at the lowest to 375 at the highest, and I went ahead and I made this grid big enough so that you could count by 25s. So we'll go 25, 50, 75, 100, 25, 50, 75, 100, 25, 50, 75, 100, 25, 50, 75, 100. All right. And then if you leave a space here, we're going to do 2 bars. We're going to do one for DVDs and one for TVs. So first we have the store is Ace. They had 140 DVD players and 65 TVs that they sold. So 140 for DVDs. If this is 120, this is 125, this is 150. So 140 would be about here. And then for TVs, it was 65. So this is 75. want to do 65. And to differentiate between the two bars, you could do them two different colors. You could shade one and not the other. What I ended up doing is I'm going to shade the DVDs. So here's the DVD sales. All right, then I'm going to skip a space, and next I'll do Wilson's. So Wilson's had 172 DVD players, so 175 is right here. 172 would just be a little bit less. And then 130 for TVs. 125 is right here, so 130 is a little bit more. I'm going to skip a space. This will be Martin's. Martin's is 185. So here's 175, 185. Um, 200 TVs. And if you're wondering where I'm getting the numbers from, I'm just looking up here at this chart. Skip a space, cost less. $195. And then 285 for the TVs. So 275 is here, 285 is right here. Right, so here's 190. And then 375. Okay, so this is the number sold. This is the name of the store. We have DVD players and TVs. All right, so that's it for bar graphs. Next, we have line graphs. This is another type of way that data can be graphed. A line graph is a display that shows the change in quantity, usually as it changes over a period of time. So here we have an example of a broken line graph that shows the monthly sales of tires at Treadwell Tire Company. Each dot represents the number of tires, sold in a given month. Straight line segments connect the dots to show the monthly fluctuation in sales. So across the vertical axis, we have the number of tires sold. The horizontal axis has the month. It is not necessary to start line graphs at 0 because they emphasize changes and patterns over time. So that's something important to note. All right, it says how many tires were sold during the first 3 months of the year combined. So January, February, March, how many tires? So we have, looks like 575 in January. We have 650 in February and 700 in March. So 1,925 tires were sold in the first 3 months combined. During which 2 consecutive months did the largest drop in sales occur, and by what % did the sales decrease? So if you wanted the largest drop in sales occur, then you're looking for the steepness of the line, and you're looking for the steepness to have a downward slant. So this would be steep, but that would be an increase in sales. Here's an increase in sales. We want steepness that is a decrease in sales. So this is pretty steep right here for this month and this month. These are 2 consecutive months. They're in a row. And then here's another steep line here. And it looks like this line is more steep than the other line. You can just imagine that you were like skiing or snowboarding or something. This one would be a little bit scary or a little bit faster. So this is what we're looking at right here. We're looking at October to November. So we have to write down the numbers for each of those. The October number is 750. The November number is 600. So to calculate the % decrease, you can do the new value, which would be November, minus the original value, which would be October, divided by the original value. If it's an increase in sales, you'll have a positive value. If it's a decrease in sales, you'll have a negative value. So November minus October divided by October. So this is our %, and we know it's decrease because it's negative. I went ahead and put a 0 on the end so that I could take my decimal and move it over twice. So this is a 20% decrease. All right, the following double line graph shows the U.S. production of oats and barley from 2003 to 2014. So on the side, we have the production of barley, and this says in 1,000 bushels. So they're saying that each number represented here is actually being multiplied by 1,000. So that's important when we answer our questions. And then down here, we have the year. It says, notice that time is typically labeled along the horizontal axis, and quantity, or the number of something, is labeled along the vertical axis. So that's just typical for these graphs. It doesn't mean they're wrong if they're not drawn that way, it's just typical. So what was the highest production of barley? So barley is the dark line, oats is the lighter line. The highest production is this dot right up here, which is 300,000, but it's not really 300,000 because each of these numbers here is multiplied by 1,000. So 300,000 multiplied by 1,000. Sorry, it wasn't 300,000. It's just under 300,000. Let me fix my number. It's whatever this line is that's just under 300,000. So it looks like these go by twos. 200, 220, 240, 260, 280, then 300. Okay, so 280,000 multiplied by 1,000. So this is the multiplication we have to do to take into account that they said that the production is in the 1,000s of bushels rather than the actual number that they labeled there. So it's probably going to give this to us in scientific notation. Oh, no, it didn't. Okay, so we can go ahead and write this down. 1, 2, 3, 4, 5, 6, 7 zeros. So hundreds, thousands, millions. 280 million bushels of barley is the highest production. When was the largest gap in production between barley and oats, and how big was the gap? Okay, so they're asking like how far apart was the biggest gap between the production. And so I'm going to look where I think my biggest gaps are. And then I'm just going to count and see which one is actually the biggest. I think those are my spots. This one might be it. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8. So there was 8 lines and a little bit extra. 1, 2, 3, 4, 5, 6, 7 and a half. Okay, so it's not this one. 1, 2, 3, 4, 5, 6, 7, 8 exactly. So it's not that one because this one was a little bit more than 8. 1, 2, 3, 4, 5, 6, 7 3/4. Okay. So it looks like it was this one. 1, 2, 3, 4, 5, 6, 7, 8 and a little bit extra. Yeah. So when was the largest gap in production? It was in 2004. And how big was the gap? It was a little bit more than 8 lines worth. And we know that each line is 20,000. So 20, 40, 60, 80, 100, 20, 40, 60. So a little bit more than 160,000, maybe 165. So 165,000, but we know that the markings along the side are not what they actually seem to be. They are in the 1,000s of bushels. So I have to take this and multiply it by 1,000. $165 million bushels was the gap. All right, here it says the following tables show a company's average unit production cost and average shipping cost for an electric component during the years 2012 to 2017. Combine the two tables into a double line graph. So we're just going to be drawing 2 different lines. We have the years 2012 to 2017, and I made it so that you could space those out evenly here. So we have 2012 2013, 2014, 2015, 2016, 2017. All right, so this is the year. And then I made it so that these dollar amounts went from $5 to $7, starting at 5, and I made them go up by 20 cents. So 5, 20, 40, 60, 80, $6. 20, 40, 60, 80, $7. And so across this side, we're going to say cost. Okay. So the first one says for 2012, it was $5.16. So $5 even, $5.20, $5.16 is somewhere like right there. $5.33 is next. So $5.20, $5.40, $5.30, $5.33. Here's $5, $5.10, $5.04, 20, 40, 60, 57, then 6, 20, 40, 60, 55, 690, okay, so here is the production cost. And then go ahead and pause the video and do another line for shipping cost. You can do it in another color. You could do it in a pen instead of a pencil. When I did mine, I went ahead and did a dotted line instead of a solid line. So go ahead and pause the video, figure out the shipping cost, and then when you are ready and have the second line drawn, then unpause the video and check, and you'll see if yours is right. All right, here is what your second graph should look like. I drew a dotted line for mine for the shipping costs. Go ahead and make sure yours looks like that. All right, so next we're going to talk about circle graphs. A circle graph is used to show what percent of the whole of some quantity is represented by its separate parts. So we have a circle graph that gives the distribution of questions contained on a comprehensive welding exam. And so some of the questions are on occupational skills, some are on quality control, some are cutting applications, some are gouging applications, some are welding applications. So the first question says, what topic was asked about the least? So over here we have gouging applications is the smallest slice of pie. So that was asked about the least. If there were 150 questions on the exam, how many of those questions deal with occupational skills? Occupational skills is 24% of the exam. So we would take 24% written as a decimal, 0.24. And multiply it by 150 questions. "36 questions would be on occupational skills. If there were 125 questions on the exam, how many would deal with quality control? If quality control is 16%, and there is 125 questions on the exam, then 16% of 125 is 20. Then that means that 20 of the questions would be on quality control. So one thing to keep in mind is that when you have a circle graph, if you create a circle graph, all of the percentages should always add up to 100 because it should be 100% of the information. All right, so what we're going to do next is we're going to take this table and we're going to create a circle graph for it. So it says this table shows the share of total electricity generated by major U.S. energy sources in 2014. They want us to create a circle graph. So they gave us the percentages for each of the energy sources, and what we need to do is we need to take a circle that has been divided into 360 degrees, because there's 360 degrees in a circle, and we need to figure out how many degrees of that circle each percentage should get. So first they did 39% of 360 is about 140 degrees, and if you notice, they rounded. 39% of 360 is 140.4. We are not going to be able to draw 0.4 degrees, and so we're just going to draw 140 degrees. So these are all going to be approximate values. So next we have 27% of 360 degrees. 97.2, I'm just going to draw 97% for that one. Or sorry, 97 degrees for that one. 19% of 360 is 68 degrees, is what I'm going to draw. 6%, 0.06 of 360 is 21.6%, so I'm going to draw 22. Sorry, I keep saying percent. I mean degrees. I'm going to draw 22 degrees for that one. 4.8%, I'm going to write as a decimal, 0.048. Let's see how many degrees I should draw. 17 degrees. And then last, 4.2%, 0.042 of 360. 15 degrees is what I'll draw. Okay. Now, in this drawing of a circle that I gave you, each of these little markings goes by 10 degrees. So whenever I have something like this to draw, I'm always going to start with what is easiest to draw first, and 140 degrees is going to be the easiest for me to draw first. So I'm going to start by drawing a radius. It doesn't matter where you draw it, I'm just going to draw this one. And then I'm going to count out 140 degrees. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. So this is 39%, and this is coal. And I'm making sure that 140 is not what I'm writing here. I am writing 39%. So coal, this one's done. Now, next I have to figure out what would be easiest to draw after this. I can see that these two, 68 and 22, they add up to 90. So on their own, they're not very easy to draw, but together they're easy to draw. So I'm going to draw those two next. So I'm going to count 10, 20, 30, 40, 50, 60, 70. I'm going to do 2 degrees less than 70, 80, 90. So here's my 78, or sorry, here's my 68, 2 degrees less than 70. There's my 68. There's my 22. $68 degrees, 22 degrees. So 68 degrees was 19%. 22 degrees is 6%. My 19% was nuclear. My 6% was hydropower. Okay, so these are done. Okay. Next, I have 97%, 17%, and 15%. 97% might be the next easiest to draw. It's just a little bit less than 100. So I'm going to do 10, 20, 30, 40, 50, 60, 70, 80, 90. 97 is almost that whole thing. Okay, 27%. I think I was saying percent. I meant degrees. I'm sorry, I keep mixing those up. Okay, 27% is natural gas. Okay, and then I have to do 15 degrees, and I have to do 17 degrees. So 15 degrees is going to be 10 and then half of a space. And then 17 is going to be 10, this 5, and this little bit extra. So we got the end bit here. And it's okay if it's not perfect because we did have decimals on all of these that we rounded a bit. So 15, this is 4.2%. This is 4.8%. The 4.8 was wind and solar. The 4.2 was other. So that is how you draw a circle graph. You have to figure out, you have to apply your percentages to 360 degrees, and then hopefully have a circle that has the little markings every 10 degrees for you.